Okay, to finish off this exercise, what we're going to do now, we're going to sort of go full circle and go back to where we started from. Okay, so if you remember these questions at the very beginning, okay, that we discussed, and that's why we use logarithms to an extent to actually work out a power. In this case, if I wanted to solve this, I use a logarithm, wouldn't I? If I wanted to work out x, because I somehow got to get that 3 over the other side, and that creates a logarithm to the base 3, doesn't it? Okay, so if you remember doing that process, okay, and I can work out that power then x, because it gives me a logarithm to the base 3 of 20, okay, and I can get my answer. Alright, there is another way of doing it though, okay, and it is kind of important I show you this other way, because you'll get more complicated ones than this, and the other way makes life a bit easier. So what we can do, right, I'll write it out again here and show you this other way, okay, and I want you to sort of think back to the previous exercise where I was solving equations and I had a single logarithm on both sides, okay. If you remember, when you've got a single logarithm on both sides, you can cancel them, can't you? They disappear, they cancel each other out. Well, I can do that process now, but the opposite way. In other words, I can introduce a logarithm by having a logarithm on both sides, okay? Because it's not going to create any problem because both sides are going to be balanced. It's just like, you know, going back to equation. You know, if you've got an equation that you don't like, maybe there's fractions in there, and you think, well, I'm going to double both sides. I'm going to double both sides to make it easier. And it's the same thing here. I'm going to take logs of both sides, okay? It's still going to be balanced. Now, when I take logs of both sides, okay, you might be thinking, well, okay, if I take logs of both sides, what's the base going to be, okay? And do you know what? It doesn't matter what base you use, so long as you're consistent. So if I use log to the base 3 here, I've got to have log to the base 3 here. So it really doesn't matter, okay? What I would advise you to do is always to take log to the base 10, okay? Right, and there is a reason for that, okay? And I'll explain now why that is kind of helpful. Main reason is, if you use log to the base 10, you don't have to keep writing the base down all the time. You could just simply write it as log of 3 to the x equals log 20. Okay, you don't need to write the base down. It's accepted, okay? For whenever the base is 10, you don't actually have to write 10 down. So an examiner will know you mean log to the base 10 here. Okay, it's got its own sort of special notation, log to the base 10, because it's so important. Okay, so that's why I would advise you to use log to the base 10. It saves you having to write it. Okay, but the examiner will know as well. Okay, so how do you go from here? What you do to proceed? Well, quite simply, you go back to the third law that we learnt. Okay, notice here we've got a power. Well, I can bring that power down in front. So I'll have x log 3 equals log 20. Okay, so yeah, we're using the power law. So you bring the power that we've got here down in front. And then all I've got to do, one more step, is to get x on its own, because that's what I want to work out. You just got to think, well, let's take that log over the other side, yeah? Because it is x times log 3, isn't it? So when you take it over, you do the inverse operation and you divide it. Okay, you just got to appreciate we're timesing here, yeah? So take it over and we divide. So my calculator, okay, I will get the answer. So use this button here, log of course. So I'll put 10 in there, 20, divide by then, use the fraction button if you want, log to this 10 of 3. And it comes out to be 2.7268 to 4 decimal places. Let me just show you, it doesn't matter what base you use. So if I used base of 8, as long as I'm consistent, base of 8 there, it would still come out to be the same, right? Okay, and let's just check then, that's my answer. Let's check that it is the same as the simpler way that I showed you to start. And it is, isn't it? 2.7268, okay? So both processes work. That obviously is a lot quicker. This takes a bit more time, but there is a reason why this actually you might find more helpful, as we see now in the next video. Okay.